All right, guys, we're going to talk quickly about null and alternative hypotheses. So whenever you try to prove something, you make a null and an alternative hypothesis. And I like to call it the ho-ha. The ho and the ha. The ho and the ha. The null and its alternative. And this is how you write it. It's a capital H sub O, subscript O, colon, then you write it in words or in symbols. And capital H sub A, which is an alternative hypothesis, colon, then you write it in words or in symbols. But here's the gist of it. The null hypothesis is the boring hypothesis. It's the, oh man, why did I waste all this time hypothesis, the treatment didn't work hypothesis, the 25% of the people still like Elvis hypothesis, the, whatever it is, it's the nothing has changed hypothesis. The alternative is usually the thing you're trying to prove or trying to figure out. If they're like, oh, I wonder, do more people like Honda Civics now than they used to? Well, then your alternative is more people like Honda Civics now. Your null would be the same amount of people. Nothing's changed like Honda Civics. So if you read the question, you should ask yourself, what am I trying to figure out? That's your alternative. And then your null is the boring hypothesis, nothing's changed. So if you're reading a question, it's like back in 2000, 25% of freshmen liked cheese. You're going to stop. Boom. Back then. Okay? And the question will go on. You go out and you find, if you ask 40 people whether or not they like cheese, blah, 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 blah. Then the question will say, has the cheese preference changed or has cheese preference increased? Well, it said back in the day, 30, whatever, I don't remember what I said, but like 30% like cheese. So your null hypothesis is 30% still like cheese. So your null hypothesis is 30% still like cheese. And then you go on and you read at the end, it says, oh, has this increased? Well, let's see, has it increased? You want to prove it has increased. That's your alternative. That has gone above. Okay? In words, it would say 30% of these kids still like cheese. This is saying it's increased. More than 30% like cheese now. Okay? If the wording asked, has that percent changed, meaning did it go up or down, you're not going to say this. You're going to say, has it changed? Is it not equal to 30% now? And what you run is a two-tail test. So we'll talk about that later on. But this is saying 30% still like cheese. Now it's not 30% anymore, it's changed, okay? You could write it in words or in symbols. Now, the biggest mistake people make are this. They say, oh, what? No. You don't have to make a hypothesis about your sample proportion. Don't forget, P is a parameter. That's the true percent of people that like cheese. P hat is your sample statistic. That's the percent that like cheese in your sample. You don't have to write a hypothesis about your sample. If you ask 30 people and 15 like cheese, you know your p hat is 0.5. So you don't have to make a hypothesis. Let's hypothesize that. No, you know it's 0.5, but that's your p hat. You make hypotheses about the population. Okay? This is the population parameter. This is the population parameter. That's what's out there. We're trying to figure out if it's changed. So we take a sample. It's the process of inference. We take a sample, calculate a statistic, and then make an inference about the population parameter. Okay? That's the whole process of inference. So there's one example. You might see something like, the average person can, Back in 2010, the average freshman could balance 7 books on the side of their face. Has this increased? Okay. Well, let's do the null boring hypothesis. They can still, on average, balance 7 books on their face. Nothing's changed. That the true average amount of books a freshman can balance on their face is still 7. Okay? So if you take a whole bunch, it should be around 7. But you want to think it's increased. Is this thing going on? People have been balancing. Maybe it's a big thing now. People are balancing books on their face, whatever. I don't know. Has it increased? Well, let's try to prove it's gone greater than 7. Notice my hypotheses. It used to be 7. I'm going to assume it's still 7. Okay? Has it increased? Let's try to show it's increased. Okay? So we assume nothing's changed. Things are still the same hypothesis, the boring hypothesis. Okay? Now, if it said, back in 2010, the average freshman can balance 7 books on their head. Has this changed? Well, here's how you write, has it changed? Okay? This is saying it's still 7. This is saying it's not 7. It has changed. Okay? So, that's your null and your alternative hypothesis. The big mistake people make here, a couple of them are, instead of mu, guess what they write? X bar. Okay, no. X bar is the mean of your sample. You don't have to make a hypothesis. If you get 40 students to balance books on their face and you find the average of those balancing people's faces was 6.2, you've got an X bar of 6.2, you know what your X bar is. There's no reason to hypothesize about it. You don't make a hypothesis about a sample statistic, okay? You do take a sample statistic because you want to say something about mu, the true average, the average that all students can balance on their face. So our hypotheses are always about mu, okay? So you should have mu there, or you should have p there. Your sample is either an X bar or a p hat, okay? But you don't hypothesize about those because you have them, right? So again, nothing has changed, all right? So just remember, the null hypothesis, the nothing has changed, no difference hypothesis, things are still the same, right? They might do one like this. I'm wondering if there's a difference between the percent of girls who like pepperoni pizza and the percent of boys who like pepperoni pizza. Okay, well, let's assume that there is no difference. If we want to see if there is a difference, let's start by saying, well, let's assume there's no difference. That the percent of males, P male, is the same as the percent of females. And we want to see if there's a significant difference. We'll say the percent male is not equal to the percent of females that like it, okay? Now, notice this is one way to write it. This is one way. No, but algebraically, you can change it real quickly. If I take this over another way, if I have the percent of males is the same as the percent of females, it's the same thing as if I subtract percent of males from both sides. I get this 0 equals PF minus PM. If the difference is 0, that means they're the same. So another way we write the same thing are, the difference between males and females is nothing. Meaning there is no difference between females and males. Let me just hold on. P female minus P male is nothing. P female minus P male is not nothing. This is saying that there is some sort of difference. The big mistake people will make here is they'll write P hat, P hat. When you do a difference between two proportions, you want to go out and take a sample of females and say, hey, what percent of you like pepperoni pizza? 40%? Males, what percent of you? 50%? Oh, okay. The difference is 10%. Is that significantly far away from 0, or could that have just happened randomly? So make sure you don't put P hats in there, okay? So you have to just be careful, but the null hypothesis, there is no difference hypothesis. Things are the same as they were in the year 2000. Basically, nothing's changed, things have changed. No difference, there is a difference. Treatment didn't work, treatment works. That's what we're doing. But always write it out in symbols, but be able to say it in words. Can you tell me what that says in the context of the problem? That's your null and your alternative hypothesis. Best of luck, guys. This is challenging stuff. If you're struggling, you're not alone. Everybody who takes stats struggles with writing this stuff right and understanding it and saying it during your introductory course, okay? You're not alone. Just keep at it. Trust me, keep at it. You will get it. And you're going to look back on it and be like, I can't believe that was confusing back then. Everything's confusing at first. You're going to get it. Stick with it. Keep reading the books. Keep trying. Keep making mistakes, and you'll get it. Okay? Have a great day.